So guys, Steven here. The IB November session is coming soon. I'm sure a lot of you guys have been practicing with past papers. And today I would like to analyze the May 2024 Time Zone 1 Paper 1 with all of you. See what is tricky and what is not. And before we start, please like, comment, and subscribe. So let's get started. So after the 3 questions, you should have all the 19 points in your bag. Okay. So let's move on to question 4. So this is finding the intersection point and then integrate it later on. So which is pretty straightforward. So we find the intersection for part A, right? X coordinate for A and C. So intersection point of F and G. So part A, what we have to do, just put the G of X equals to the F of X since it's on the graph. Then we're going to copy it down from the question. Okay, so we got cosine of X equals to sine of 2X. Now this one, it's a double angle identity. So you need to expand it. Okay, double angle identity. And don't worry, you can actually find this one from your formula booklet. Okay, so let's see the formula booklet. So we have the angles. Yep, there you go. See? Now sine, see here, sine 2 theta, 2 sine theta, cosine theta. Just see it and then apply it here. So we have to rewrite this one as still cosine x, but equals to 2 sine x and then cosine x. All right. Then the next step is, oh, both sides got that cosine x. So we can just cancel it out and then write it as 1 equals to 2 sine x. Okay, so far so good. If you say so far so good, then you're pretty much have a high chance of getting cooked. Why? Because if you directly cancel out one of this cosine x, you will actually lose one of your answers. Okay, let me show you later. Okay, instead, what we should do is we try not to directly cancel them out. All right. The correct way that we should do it is with both sides subtract the cosine x. So we're gonna make it 0 equals to 2 sine x cosine x subtract the cosine x. Okay, then we have to use factorization. So we take the cosine x out of it. So cosine x out of it, and then 2 sine x minus 1 equals to 0. All right, and that's give us 2 sets of solution because this one cosine x could be equal to 0, or this 2 sine x minus 1 could be equal to 0. All right, and why we have to reject one of the answer, which is the cosine x equals to 0, it's because this is the point. This is the point of point B. All right. See, now x equals to 0, right? It has a y value equal to 0, but it tells us to find A and C only. So when it hits the y value equal to 0 for cosine x equal to 0, this one we don't need to show it. So this one we can just directly ignore it, okay? Reject it. Not exactly reject, but we just don't need to consider it as of now, okay? So then we just consider the 2 sine x minus 1 equals to 0. So sine x equals to 1 over 2. Now, 1 over 2, my personal habit is to construct the famous triangles. So which is the 30, 60, 30, 60, 90, okay? And I specifically make it as obvious as possible. The narrow angle, make it 30, okay? Then label it as at the narrow side, 1, and then the hypotenuse always a 2. This is a root 3. 1, 2, root 3. Always remember. Okay? So sine of 1 over 2, then you can trace it back at 1, 2, and then the sine, which is the 30 degrees. Okay? But this case, we look at the axis. This axis is in terms of pi. That means we should be using radian. All right? So 30 degrees in radian, so x could be, sorry, I use black pen again. So x equals to, now 30 degrees, right? 30 times pi over 180, so this is 6. Okay, so it's just pi over 6, okay? And that's give us one of the points, right? And if you remember from the CAST graph, okay, not just on the first quadrant, you will have this 30 degrees. You're also in the sine quadrant, right? The 30 degrees also looks like this. So that means this is just 30 degrees, which means the actual angle, it is 180 subtract 30, which is 150 degrees. All right. So that means our next answer, or which is pi, pi stands for 180 degrees, right? And then we're going to subtract our 30 degrees, okay, which is 150. So this one, or pi subtract pi over 6, which is 5 pi over 6, okay? So now we have the two sets of answers. Okay, so point A, it's pi over 6. C, it's 5 pi over 6. Now, shaded region R, it's here, right? Find the area of R. It's a typical integration question, pretty straightforward. So write the integral sign, compare where they start, where they finish, okay? So this start from the middle. Now, the middle, this is actually a cosine graph, right? So if that's the pi, here should be pi over 2, right? So we're integrating from the pi over 2 all the way up to the c, which is our 5 pi over 6. So 5 pi over 6. Then you need to observe the top curve subtract the bottom curve, okay? So which one is the top curve? The top curve, it's the f, right? So f of x. The bottom curve is the g of x. So in this case, you should be writing something like the g of x, sorry, it's the f of x subtracting the g of x, all right? So the f of x is cosine x. So we write down cosine x subtracting sine of 2x. Bracket it and then integrate it, all right? That's a pretty straightforward one. So we just integrate it. The cosine x will give us sine x, right? Okay, but then the negative sign, pay attention. This is still minus, okay? But if you take away only particularly this part and then try to do a little bit of analysis, it's you can use u sub, which is u equals to 2x. So du dx, it's 2. So dx is equals to du over 2. All right, so that means the sine u, and then you have to integrate it with du over 2. So 1 over 2, and then sine u du, which is 1 over 2 times the negative cosine x, oh, cosine u, sorry. All right, so if we put this one back there, we bracket it, write it down, negative times half times negative cosine of 2x, close bracket, and then the square bracket, 5 pi over 6 pi over 2. So, which is sine x plus half of cosine 2x. And then substitute with 5 pi over 6 and pi over 2. Now this one, just be careful while you're substituting it, that should be fine. Let's do it quickly. We draw the two big brackets first, okay? This is my usual practice. Actually, brackets can save your life quite a lot. So we're going to have sine of 5 pi over 6 plus half of cosine of 2 times 5 pi over 6 minus sine of pi over 2 plus half of cosine of 2 times pi over 2. Okay? So now sine of 5 pi over 6, we actually just drew it here, right? So this is 150 degrees. So that would give us, this one will give us 1 over 2. All right? So now 2 times that, what is cosine? Cosine of 2 times that, which is cosine of 5 pi over 3. So 5 pi over 3, that's how many? Or that's gonna be, nah, which is now 5 pi over 3 times pi over 180. So this is 60, this is 1. Pi cancel out, which is 300, right? 300, which it should be here. And that's 60 degrees short from being a complete cycle, right? So from our famous triangles, this should be a 1. Hypotenuse always the 2. That's the root 3, right? So the cosine of that should be 1 over 2 still. So we have to plus the half times the half, right? Okay. So now close the two brackets minus sine of pi over 2. Pi over 2, which is 90 degrees, right? So sine 90, draw the sine graph. This is 2 pi, this is pi. That's going to be pi over 2. And this one will give us a 1. So minus 1 plus how many? So this is cosine of pi. Now cosine of pi, now let's see, cosine of pi. So this is the cosine graph. Cosine of this is 2 pi. Cosine of pi, which is at -1. Okay? So that means we have to put plus half times -1. All right? So tricky. So this is a half plus 1/4. Subtracting bracket 1 minus a half, which is 1 over 2 plus 1 over 4 minus 1 over 2, which is 1 over 4 as the answer. This one is pretty tricky, okay? So please be careful. All right, now question 5 starts to be a little bit harder. Part A is fine, pretty straightforward. So directly use the formula book, and then you should be able to find this one. All right, so U1, the sum of n is actually U1 times r to the power of n minus 1 over r minus 1, right? Now our U1, it's a 1, right? Bracket times 10 to the power of n minus 1 over 10 minus 1, which is 10 to the power of n minus 1 over 9. That's it. Okay? Now part B. Now part B is the tricky one. Since I don't know what to do with it, so maybe we can think about how we should be handling this question. So if we add them up, what do we see? Now, it is not a geometric sequence, nor an arithmetic sequence purely by its own. So we probably have to list it out a little bit. So maybe we find S1 first. Now, S1 is pretty standard, which is 10 to the power of 1 minus 1 over 9, right? Which is what it is, okay? Then what about S2? S2 is actually going to be 10 squared minus 1 over 9. And then S3, that's going to be 10 cubed minus 1 over 9, right? So on and so forth. So if I try to add these things up, so from S1 adding S2, adding S3, adding all the way to Sn, I will probably see something like 10 to the power of 1 minus 1 over 9 plus 10 to the power of 2 minus 1 over 9 plus 10 to the power of 3 minus 1 over 9, all the way up to the 10 to the power of n minus 1 over 9, right? Okay, so now every single of them has the common denominator of 9, right? So that means we can take away the 1 over 9 first, times, okay, now it's 10 to the power of 1 minus 1 bracket plus 10 squared minus 1 plus 10 cubed minus 1 all the way up to plus 10 to the power of n minus 1. So the next step we should do is try to group them a little bit since they follow the same pattern, right? So that means here now we see a pattern there, right? So we can then separate the 1 over 9 first, then the 10 squared, 10 cubed, all the way up to the n to the power of n. It could be formed by its own. And then how many ones am I trying to subtract them? These ones, how many of them? There are actually n of them, right? So at the end, we're actually minusing 1 times n, right? Okay. So we're going to have 1 over 9 times that, basically the same thing. But the thing is, now we try to simplify this part a little bit. So it follows a geometric sequence, right? Now, if we use the top area to list them out, which is from 10 to the power of 1, and then 10 to the power of 2, 10 to the power of 3, right? And so on and so forth until 10 to the power of n. And then this is the sum of a geometric sequence. We use the formula one more time, which is the first term times the r to the power of n minus 1 over r minus 1, right? So the first term now, instead of a 1, that's a 10. And then our common ratio is also a 10. N minus 1 over, so 10 minus 1, that's also a 9, right? So now we can successfully replace this part with a simplified version of 1 over 9, and then bracket, and then times the 10 times 10 to the power of r minus 1, close bracket, over 9, and then minus n, close bracket. Okay? So, and if we simplify a little bit, that's going to be 1 over 9 times the 10 times 10 to the power of r minus 1 minus 9n over 9, because this particular n we simplified it as 9n over 9. Okay, and then combine them and then make them the same denominator by 10 times 10 to the power of r minus 1 minus 9n over 81. That's it. Okay, so that's going to be part B of question 5. Okay, now question 6, that's still pretty straightforward. Okay, nothing too fancy. So rotated by 2 pi radian, that means a complete 360-degree, and then revolving about this part. Okay, so it will form a solid somewhat like this. Okay, so that's the r, and then the radius is actually the height of here. Okay, so if you remember how to do the recurring things, it should be, we're trying to integrate, basically we're trying to integrate the pi r square, and then with respect to the x. Okay, and this is in terms of x. So now we have the boundary from 0 to pi over 2. So integrate from 0 to pi over 2, then times pi something square with respect to dx, right? That's pi r square. And that's, we call it the disk method. Okay, so what is the formula here? We have square root of x sine x squared. So the inside, it's square root of x sine bracket x squared. Okay. Now the first step, there are actually two first steps you can do. First of all, take away the constant out of it, then simplify these two. Okay. But of course, the right hands, you can't write it on the paper. So we put outside pi times 0, and then pi over 2, then times x sine bracket x squared dx. Okay. We have to use u sub in this case. So let u gonna be the x squared du dx equals to 2x. And then we make dx a subject, so dx will be du over 2x. Now this dx is trying to replace this part a little bit. And this x squared is going to be replaced with the u. And do not forget about this thing, okay? So if u equals to x squared, now, because originally this one trying to replace the x, right? So we're going to substitute this one back into here. Oh, sorry, it's not. Oh, it's pi over 2. Sorry, I forget to put the square. Square root. Okay, so we put the u that's equals to basically the pi root x. Oh, sorry, root pi over 2. What am I doing? For 2 square, which is pi over 4. Okay, now 0, which is 0, so that doesn't change anything. So it's just pi, and then integrate from 0 to now pi over 4. Okay, and then x times sine u. Now the dx replace it with du over 2x. Now the x and x cancel out. Again, you don't have to write it on your paper. Okay, I just demonstrated to you. Okay, now this over 2, that's a constant. You can get it out as well. So we can then write it as pi over 2, and then integral 0 pi over 4 sine u du. Okay, so how do we get sine u? It's, you remember now, if we differentiate cosine x, we got negative sign, right? So now we make sure we need to give the negative back to it. Okay. So is it sign? Yes, that's a sign. So that means we're gonna have pi over 2 times the negative cosine u. Okay. And then with the value substitute from pi over 4 and then 0. Okay. So and then equals to pi over 2. Now put a big bracket there. Okay. And then two things subtract each other, right? So we're gonna have negative cosine of pi over 4 subtracting negative cosine of 0. Okay. So this one is actually 45 degrees, right? So pi is 180 divided by 4, which is 45. Okay. So cosine 45, 45, 45, which is 1 over 2. So 1 over root 2. Okay. So that means we have a equals to pi over 2 times negative 1 over root 2. Okay. And then now minus the negative cosine 0. Cosine 0, what is cosine 0? We draw the cosine curve, okay? Cosine 0, it's at a 1. So that means that if I write it clearly, this part, it's a 1. So this part, it's a negative 1. You minus a negative 1, that gives you plus 1, right? Okay. So then if we simplify a little bit, so we're gonna have which is pi over 2 times basically 1 minus root 2 over 2, right? And we write the 1 as 2 over 2. So 2 minus root 2 over the entire 2. And then we're gonna have equals to pi bracket 2 minus root 2 over bottom times bottom is a 4. And that's exactly how we find it. 7. We use mathematical induction and this definition to prove that this works. So for any mathematical induction, or most of them, we have to begin from using when n equals to 1, okay? So when n equals to 1, what will happen? It's the summation sign. It's the summation of r equals to 1 up to the 1. That's gonna be what? That's gonna be like this, right? That's equals to 1c1, right? Which is equals to 1, okay? And then that's the left-hand side, right? So for the right-hand side, what do we have? We have n plus 1 and then c2. Our n is a 1, so it's 1 plus 1 c2, which means 2c2. 2c2 means we pick 2 out of 2. So that means the combination should be just 1, right? Because out of the 2 things, you pick all the 2 things. There's only 1 chance for you to doing that, okay? So then you need to say that, okay, therefore, it is true for n equals to 1, all right? So after that, then you need to say something like this, and you need to make an assumption, right? So assume it is true for what? For the chances of being n equals to k. Okay? So that means if this is true, that means the summation from r equals to 1 up to the k, then that will be what? And that will be equals to k plus 1 c2, right? Okay? Make sense? That's step number 3. It's when it hits when the n it's equals to k plus 1. Okay, so what will the k plus 1 k is going to be like? Okay, so the k plus 1, then it will be from, okay, r equals to 1, and then let's reach to k plus 1, right? This is still r, this is still 1, right? Okay, so this is, yeah. And then that should be equals to what? That should equals to k plus 1 of the C2. Make sense? Okay, so then the things that we want to show right now is C. We try to verify a little bit. We try to verify if this is equals to this. Okay, so this is actually the conclusion. Okay, then we're gonna separate it later. Okay, this is our goal. This is our end goal here. Okay. Okay. So now let's try to calculate the left-hand side a little bit first. Okay. So if we want to do it, what does it mean? That means that from the k plus one term, adding the k term, adding anything below it, right? So we can then separate a little bit as the sum from the first term up to the k, and then plus the last term, right? Which is the k plus one term, which is the k plus one term like this. Okay, makes sense? So now if we simplify a little bit, what do we have? We can then gonna have now, since we assume that this is true, right? So we can then use the definition and turn this one, what is it written up there? It is n plus 1 over 2. So that means it's k plus 1 over 2. So k plus 1 and then c2 plus k plus 1 and then c1. Okay? So with the definition of n factorial, which is the k plus 1 factorial over the r factorial, which means the 2 factorial, times the what n minus r, which is the k plus 1 minus 2 factorial. And then we have to plus what? We have to plus the k plus 1 factorial over the 1 factorial times the, basically it's the k plus 1 minus 1, the factorial, okay? So, and then, now, this one, after we continue, we need to see what is the end goal going to look like. So that's going to become basically k plus 2, c2, right? So if we use the formula, that would be k plus 2 factorial over 2 factorial, and then k plus 2 minus 2, which is actually just k factorial, okay? So if this equals to this, then it is true for this mathematical induction, okay? So let's continue to make, basically we're trying to make this one, simplify this one as close as this. So that will be, what is that? That will be k plus 1 factorial over 2 times, this is k minus 1 factorial, okay? And then plus k plus 1 factorial over k factorial, okay? So now you can see that actually on the right-hand side, this one, if we want to make them the same denominator, right? So we can then have times 2 over 2, since there's a 2 there, right? Then we can then, yeah, if the k factorial, what we can rewrite the k factorial as k times k minus 1 factorial, okay? So now we have a k there. And that means on the left-hand side, we should multiply by k over k because the bottom, that's a k. All right, so what can we do right now? It's in the next step. It's the top becomes k times k plus 1 factorial, and then plus k plus 1 factorial times 2. And then over the bottom is 2 times k minus 1 factorial, okay? Now, the k times k minus 1 factorial can be written as the k factorial, right? The 2 can be written as 2 factorial again, because 2 times 1 is the 2 factorial. It's 2. So then we can write it as the bottom, it's going to be 2 factorial k factorial. When the top, now the top, you can see that this is a common factor. We extract down out. So we're going to have k plus 1 factorial times the k plus 2. Okay. So now, now you can see that, okay, k plus 2 and then k plus 1 factorial can combine as k plus 2 factorial, right? Because k plus 2 and then the times, right? Times the k plus 1 times the k times the k minus 1 up to the end, right? So this one, that's going to be k plus 2 factorial. And in the front, this one is actually the k plus 1 factorial, okay? So that means this one is equals to k plus 2 whole thing factorial over 2 factorial k factorial, which is exactly the same as the right-hand side of our goal, which is the a plus 1 plus 1 c2. Okay? And this is how you do it. So then you need to state some lines again. So you have to say, okay, since it's true for n equals to 1, for n equals to k, then you can then use these two to imply that, okay, then implies, and it is true, for n equals to k plus 1 as well, okay? And which is true for all n's, okay? So that's going to be question 7. So question 8, pretty straightforward. Use the formula. This is Maclaurin series, not Maclaurin series. Watch too much Formula 1 going on there. So let's look at the Maclaurin series. Where's the Maclaurin? Where is it on the formula book? I remember there's one. Right, there you go. Okay, so now this is sine, right? Look at here, the sine version for that. So we can then do it quickly. This is, I would say it's a 1-star question because it's too easy. You just follow the formula booklet. So sine x squared expanded, you can then have, which is you bracketed x squared, right? And then minus the x squared bracket to the power of 3 over the 3 factorial, and then plus da 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 da. We only need the first 2 times, okay? So we can write it as x squared minus x to the power of 6 over 6 plus da da da. Okay? Now, and then for part B, it's the sine square of the x squared. Okay, so since we do the A1 already, that's not B. That's A2. My bad. A1, A2. That means we can then just use the sine of x squared, the whole thing called square, right? Which means we can use the part A1 answer, which is the bracket something square, but that's x squared minus x to the 6 over 6 plus the square. Which is what? Which is actually just copy it twice. X squared minus x 6 over 6 plus times x squared minus x 6 over 6 plus Now, if you distribute a little bit, the x times this, then followed by this times this, and then this times this. So the first one is x to the 4 minus, x squared times x to the power of 6 over 6 minus, again, it's an x squared times x to the power of 6 over 6, and then plus the remaining stuff, okay? Because you see here, this is to the power of 4, right? This one later on combined as x to the power of 8. And we combine these two, that's the second term, right? Second term, that's going to be the first term, right? And then the rest of them, if we multiply these two together, that will be x to the power of 12, which is the third term already. Third term or later. So we don't need this one, okay? So if we continue, then we can simplify it as equals to x to the power of 4 minus x to the power of 8 over 6 minus x to the power of 8 over 6 plus da 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 da. So that means twice of the remaining these two. So x to the power of 4 minus x to the power of 8 over 3, because that's 2 of them, right? And then plus da 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 da. That's it. All right. B, hence, find the first 2 non-zero terms of the Maclaurin series of 4 sine x squared cosine x squared. Now it looks like one of the expanded version of the double angle identity. So let me find it first. It's always struggle to find the correct formula in the formula booklet. Okay, so for part B, let's write it out as 4x, right? 4x times sine bracket x squared cosine x squared, right? So if you want to analyze a little bit, it looks like the case for sine 2x equals to 2 sine x cosine x, right? But then this is x squared. So you just think about this is actually sine of a smiley face. This is cosine of a smiley face, okay? Then at the end, it's going to be sine of 2 smiley face, okay? Except this smiley face is just an x squared, okay? So this one, let's separate it a little bit. So 2x times 2 times sine of x squared cosine x squared, bracket, okay? Then these part can be combined as what? 2, sorry, not 2. It's the sine of 2 times the smiley face, which is the x squared, okay? So then this is going to be 2x times that, right? 2x times sine x, which is the 2x squared, okay? And then minus 2x squared cubed over 3 factorial plus okay? Make sure you have the plus at the end, okay? So then you're gonna have 2x times your 2x squared minus 8x to the power of 二三得六. Okay, and over 3 factorial, which is a 6 plus okay? Now, and then you simplify, distribute this one into here and here. You're gonna have 4x to the power of 3 minus, simplify this 8x to the power of 7 over 3. Yep, plus okay? Because this is actually x to the power of 1. 1 combined with the 6 is x to the power of 1 plus 6. That's how you get x to the power of 7. Okay? So that's the answer for that. Question 9, graph transformation a little bit. Now, if you recall a little bit of what it's the absolute functions, the absolute function, this one, if we apply the absolute function to our input, it's basically the reflection of the positive side. Okay, so you can actually see, okay, this one actually looks like a mirror. Whatever on the right hand side, flip to the left hand side. All right, so that's the absolute function applied to the function. Okay, so now sketch. If I have the absolute function outside of it, that means whatever negative y value, I have to flip it up. So that means, what do I have to do? For example, these two parts, I have to flip it up like this, okay? So that means in the first place, you need to match it up like this, and then this. Okay, so am I doing anything wrong? Actually, yes. And that's the first mistake when I first tried to do this question, but later on I corrected it. We only focus on where, that's one of the tricky things is, we're only focusing on flipping the middle part upside down, right? But at the end here, can you see that when it reaches, try to be, approaches to the -6, it's actually, these part are actually negative as well. So you have to flip those part up as well. So instead of directly write it like this, the remaining part, you need to draw it up like that as well. So draw up like this and draw up like that as well. Okay. So like this, like this, like this, and like this. Okay. So I know it's draw a little bit ugly, but you get the idea. And then sketch it. Now it's an odd function. What does it mean by odd function? That means it is actually a rotational symmetry. Rotational symmetry. Okay. If you can rotate a paper a little bit, so if the original shape gonna be look like this, right? That means it shall be, this time it's going down first, going up, then going down like this, okay? We have to make it a spiral thing, like turning a little bit around the center. So let's copy down the original shape first. The original shape shall look like smaller, bigger, going down, approaches to 6 up. Let me write it bigger. Smaller, bigger, approaches to 6 a little bit like this, okay? Then, the thing is, you need to go a little bit smaller, and then bigger in this part, and then going back up again, like this. That looks like an odd function. It's a rotational symmetry, okay? So whatever applies in here, that should be applied in here as well, okay? So now it's given that this one from 0 to 4 is 1.6. So if we see the graph one more time, then that's gonna be like this, right? Let me see. Yes. So from 0 to 4 is 1.6. Let's say here is a 6. So here is a 4. That means the net area of from 0 up to here, the net area is 1.6, okay? So if I use from -4 to the 0 of the original function, that means that's the odd function, right? So I'm talking about this particular graph, which means that here to, let's say this is a -4, up to here, right? You see, now the small one, big one subtract the small one is 1.6. Now the small one is actually flip it upside down, right? The positive becomes negative. The negative becomes the positive. So that means the net version for this, the net version, that shall be what? That shall be negative 1.6 as well. Okay, make sense? So this one, C1, that should be negative 1.6. Okay. Now for C2, okay, this one we have to separate a little bit, which is from -4 to 4 of the f of absolute x plus the dx, of course. -4 to 4 and the f of x dx again. So now this part, the first part, we look at the information that is given in the first place here. Now again, we have the what? We have the net here up the way to the 4. Here it's 1.6, right? That means here and here, that's also what? That's also netting of 1.6 from -4 to 0. So there are two 1.6 combined together. So this one, the first part, we can then write it as 2 times 1.6 first, okay? Then we have to add from -4, from -4 to 4 of the f of x. Since this is an odd function, whatever you cover, it will be cancelled out, right? Because you see this little uphill will cancel out with a little downhill there. The bigger negative area will cancel out with the bigger positive area there. So that means in this particular graph, the area should be 0. So that's going to be 2 times 1.6 plus a 0, which is 3.2. Okay, that marks down question 9. Okay, so moving on to section B. So in my opinion, section B consists of 3 questions, 10, 11, 12. 10 and 11, they are pretty easy, to be fair. But then the last one, which is the typical imaginary number part. Okay, so this one, it will take you slightly longer time, especially for part G a little bit. The front, all of them in the front, that should be fine. Okay, so let's take a look at that together. All right, so question 10. Now, we have to use it on a separate piece of answer booklet. So I decided to use a separate paper to do it, okay? So let's just move it like this a little bit. So question 10, part A. Now, if we see here, the function is 4x plus 2 over x minus 2. Sketch the graph, indicate the value of any intercepts and the asymptotes, okay? So if you can see here, first of all, when the bottom equal to 0, that gives us the vertical asymptote, right? So when the bottom equal to 0, that means x minus 2 equals to 0. So x will be equals to 2. And this one will give us the vertical Asymptote. Right? So now, what is the horizontal asymptote? It's we have to compare their coefficients, right? So they have the same leading power from the top, which is x to the power of 1 and x to the power of 1, right? If they have the same leading power, then the horizontal asymptote will be their coefficient divided by each other, okay? So that means we can then use basically 4 divided by 1. Y equals to 4 divided by 1, which is equals to 4. Okay, and that's the horizontal asymptote. Horizontal asymptote. Okay, so if we have to sketch it out, then probably going to be like this. So that will be the number 2. That's going to be number 4. Okay, then we have to use the let's use the dash line a little bit. And for the asymptote. Okay, and then now our thinking, it could be now, it can only go in two ways. If it goes like this, or this is the first style, or it goes like maybe like this, right? It's either the blue pair or the red pair, right? So in this case, how can we determine it? We have to determine by finding the intercepts. So let's clear them out first, okay? So when x is equal to 0, what is the y? So when x is equal to 0, when x equals to 0, so y will be, or f of x is going to be 4 times 0 plus 2 over 0 minus 2. So that will give you 2 over negative 2. That's negative 1. So when x is a 0, y is a negative 1. So let's pick it like somewhere around here, negative 1. Okay. So when the y equals to 0, then we got to solve for the x, right? 4x plus 2 over x minus 2. So 0 plus 2 times there, that will be still 0. So 4x plus 2. So minus 2 equals to 4x. X equals to negative 1 over 2. So this is negative 1 over 2. So that means it is reasonably okay to draw the graph like this. A little bit more neat and tidy, and then going down like that. Okay. And then for sure, just going to close like this. Okay. So that's how briefly you can sketch the graph. Okay. So you get all the information: vertical asymptote, horizontal asymptote, intercept 1, intercept 2. Okay. So that's going to be how you do question A. Write down the range of f. Now, the range is pretty straightforward because if I would use a test called a ruler test, okay? I draw a horizontal line like this, okay? Or if you use a ruler, that also works, okay? Then I will actually scan like this, okay? If it goes up, it still touches the graph. It touches the graph around here, right? Still touches the graph, touches the graph, touches the graph, touches the graph until it's 4. Now 4, when y equals to 4, that should be not touching anywhere, okay? Because that's an asymptote, okay? And then it should be touching, 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 touching. That's called a ruler test for myself, okay? I just make it up, okay? So that means now our range should be from negative infinity up to the 4, that means or the 4 up to the positive infinity. That's for the range, okay? Now for C, so that P equals to 9 over 2. Now this is in a function of x squared plus bx plus c, and has an axis of symmetry x equals to 2. And then 2 root. So now if you think a little bit, let's roughly sketch it out first, and that's help you to think. You have an axis of symmetry at 2, right? You have one of the root. You have one of the root of negative, right? And that means the next root should be right there because they have the same distance away from the axis of symmetry. But how can we solve it as an algebra, which is like negative half plus the p over 2? That should equals to our axis of symmetry 2. So that means P minus half, that equals to 4. P shall equals to 4 and 1 over 2. That means 9 over 2, or 4.5. Okay? So now that's how we prove that. And then find the value of B and find the value of C. Okay. So now, because the fact that we have found the two roots, right? And then you can read the coefficient in front of the x. It's nothing, or it's a 1 only. So that means we can fairly say that's actually the g of x in the factored form. That should be x minus 9 over 2 times x plus 1 over 2, because that stands for the two different roots, right? One root is positive 9 over 2. Another root, it's negative 1 over 2, right? So we distribute a little bit, then we're going to have, that's going to be equals to x squared minus 9 over 2 plus 9 over 2x plus half x minus 9 over 4, right? So if we plus 9 over 2, that should give us x squared minus 4x minus 9 over 4, okay? So that should be the case, okay? Now, let's move on to part find value of B and C. Okay, so that means B, we have to say that B equals to negative 4, C equals negative 9 over 4. Okay? Now, find the y coordinate of the vertex. Okay. Now, the vertex of the y coordinate of the vertex that happens at the axis of symmetry. Because if you think about the graph, looks like this, right? The axis of symmetry has the same x coordinate as the vertex. So if you substitute the axis of symmetry, which is at x equals to 2, then you can find the vertex. So that's a shortcut. So part E. So the y coordinate of vertex means actually g of 2. Okay, because since x equals to 2 is the axis of symmetry. So g of 2 is equals to what? It's equals to, okay, 2 squared minus 4 times 2 minus 9 over 4. That's going to be 4 minus 8 minus 9 over 4. So negative 4 minus 9 over 4. Make them the same denominator, negative 16 over 4 minus 9 over 4, which is negative 25 over 4. It's more negative. Okay? So the y coordinate, it's going to be negative 25 over 4. For F, the product of the solution. Now, this one, you can then actually, first of all, you have to write it out first. So f of x equal to g of x. So f of x is 4x plus 2 over x minus 2, right? The g of x, if you found it correctly, and you just put it up as what? As x squared minus 4x minus 9 over 4, right? So that means when we're trying to solve for this one, we try to make it as a 0 and then find the roots, right? So 0 will equals to x minus 2 times your x squared minus 4x minus 9 over 4, right? Because we have to move the x over 2 times it, then subtract the 4x and subtract the 2. So minus 4x minus 2. All right, so distribute a little bit. We're gonna have bracket x cubed minus 4x squared minus 9 over 4x, okay? Minus, okay, again, another bracket, 2x squared minus 8x minus 18 over 4. Like, I don't simplify it because simply because maybe later on we can use that. 4x minus 2. All right, then break the bracket. That's minus 9 over 4x minus 2x squared plus 8x, and then plus, just simplify that, 9 over 2 minus 4x minus 2. Okay, group the like terms. Now x cubed and then minus 6x squared, and then we have, we just write down plus 8 minus now for 4x is okay. Oh, and then minus another 4x. Minus 4x. Okay. And what matters the most is the last term, which is the plus 9 over 2 minus 2, which is, if it's not 2, that means it's 4 over 2. This is plus 5 over 2, okay? Go back to check the formula, then you can find that this is the last term, right? And then this one is the coefficient, the an is a coefficient for the first term, okay? So now if we see that a little bit, then our answer should be the product of root. That's gonna be -1 to the power of 3, because this is to the power of 3, right? Okay, and then times the 5 over 2 divided by the coefficient of the first one, which is the 1 only. Okay, so that means you should have the answer of -5 over 2. That's it. Okay, so that's for 10F. Now moving on to question 11. So 11, then question A. So that x plus 1 is a factor of px, so we just substitute the negative version, reflect the number inside. If it is x plus 1, we use -1. Then that's going to equal to 3 times -1 cubed plus 5 times -1 square plus -1 and then minus 1. So that's going to be -3 plus 5 minus 1 minus 1, which is equal to 0. Therefore, x plus 1 is a factor of px. Okay? Hence, express px as a product, that means basically we want you to find the factored form. So we can then directly use a long substitute division. That's just personal preference. If you want to use a short division, that also works for you. Okay. So now my personal practice is I try to cover it. Okay. So if I cover the rest of the term, I only see the 3x squared, 3x cubed. Okay, 3x cubed is not enough to divide, so we are moving on to the 5x squared cube. Okay. So now what should we multiply in the first place? Put it here. It should be 3x squared, because the 3 squared times 6 is 3x cubed. So we can cancel out the first one. So we multiply that 3x cubed plus 3x squared. Subtracted 2x squared plus x. So plus the times 2x. 2x times x is 2x squared plus 2x. Subtracted x minus the positive x, we have -x minus 1. So at the end, just minus 1. So minus x minus 1. That's it. Okay. So now our px will be equals to x plus 1 times 3x squared plus 2x minus 1. But we have to further factorize this one a little bit. Okay. So now 3x squared and then 3x, if you use the cross method, times x. So this is the -1 plus 1, cross multiply, -x plus 3x. That will give us positive 2x, right? So, and then we read the answer horizontally. This is our root, this is our root. So therefore, the px will be equal to x plus 1 times 3x minus 1 times x plus 1 again. Okay, so you can rewrite as 3x minus 1 times x plus 1 whole square. That also works. All right. So B completed. C. Express 1 over qx as a over that and b over that. Okay, so let's do that. 1 over q of x, which is equals to, where's the q of x? The q of x is that, so which is, okay, we just write it down from it first. So a over x plus 1 plus b times 2x plus 1. So that one will give us, so basically, if we simplify that, we can cross multiply that a times 2x plus 1, and then plus b times x plus 1 over x plus 1 times 2x plus 1 still equal, right? So since the top is still 1 over the x plus 1 times 2x plus 1, then we can say, okay, 1 equals to, okay, 2ax plus a plus bx plus b. Now we group the like terms because in the front that should be 0x, right? So we group the like terms, then we're going to have, this is 2a plus b times x plus the a plus b. So that's going to be 0x plus 1, right? Compare the like terms and you can have 2a plus b equals to 0, a plus b equals to 1. So 2a plus b means a plus b equals to 0. So we can then replace the a plus b with the 1. So a equals to -1. If a equals to -1 plus b equals to 1, b equals to 2. That's it. Okay, hence or otherwise, show that this expression. Okay, so let's do that together. Do we have enough space? Now we move on to the next page. Part D. Part D, it's 1 over x plus 1 times the qx, which is the qx. Okay. Now we want to show that, right? That means basically we have to separate this 1 over the x plus 1 first, and then times another one, right? Which is the expression that we just figured out. And what is that? That's actually going to be the one that we just found. A is -1, right? So -1 over x plus 1 plus 2, that's the b, right? 2x plus 1. Now, if we try to distribute a little bit inside to each of them, then we can have -1 over x plus 1 squared plus 2 over x plus 1 times 2x plus 1. Okay, now see this part. This part's a little bit special because this one actually it's the doubled version of the 1 over x plus 1 times 2x plus 1, right? So basically this one could be separated back again as the -1 over x plus 1 plus 2 over x plus 1. But we just have to factorize the 2 out of it. So that will be equals to -1 over x plus 1 whole square plus 2 times the 1 over x plus 1 2x plus 1, right? So that's -1 over x plus 1 squared plus 2 times that. Just copy it down one more time, which is -1 times the x plus 1, and then plus 2 over the 2x plus 1. Okay, that's the exact expression that we can do from part C. Okay, so distribute the 2 inside, so -1 over x plus 1 whole square minus 2 over x plus 1 plus 4 over 2x plus 1. That's pretty much the style of it, but you just rearrange it a little bit. Okay, so let's just rearrange it. Okay, it's then equals to 4 over 2x plus 1 minus 2 over x plus 1 minus 1 over x plus 1 whole square. Okay, so part B completed. Part E. Hence, find the integral. Oh, so the integral of this whole thing, which is x or plus 1 squared times 2x plus 1 integral. This is basically, because it's like step by step, right? So we actually prefer you to just copy this one into here. So basically, with the integral of the 4 over 2x plus 1 minus 2 and then 2x, sorry, this is x plus 1 minus the 1 over x plus 1 squared, the whole thing dx, right? Then if you want, you can then separate as 3 different integral, but I will write it out as like this. So which is the full integral of the 2x plus 1, the whole the -1, right, dx, minus the 2 integral of the x plus 1 to the power of negative 1 dx, and then minus the integral of x plus 1 to the power of negative 2 dx. Okay, so now if you remember, if you integrate something to the power of negative 1, that will give you the natural log of that thingy, right? But for sure you get to put the absolute sum to it. It's the same case here, okay? It's the same case here. So, but then don't forget, if you're gonna have a 2x inside, make sure you need to divide it by 2 for the 4 as well. So you can then gonna have, which is equals to 2 times the natural log of absolute 2x plus 1, absolute it, okay? And then minus 2 ln absolute x plus 1, close absolute. Now this is easier. Now the power plus 1, so minus the power plus 1, which is x plus 1 negative 1, divided by new power negative 1, okay, at the end plus c. So the final answer is 2 ln 2x plus 1 minus 2 ln of x plus 1, close. Now negative, negative, they cancel out, right? So plus the, basically just 1 over x plus 1 and then plus c. That's it, okay? Then consider the function of that. Find the limit approaches to negative 1. Let's write it out the function first, okay? Fi. So the Fi is f of x equals to px over x plus 1 times the qx. Why this type question is so long? So the px is, we factorize it, right? So what is the px? The px is this 3x minus 1 times x plus 1 squared. 3x minus 1 times x, is it x plus 1 squared, okay? The bottom is x plus 1 times the qx. The qx is basically it's still squared, and then 2x plus 1, okay? So now you can see the square can cancel out, which is 3x minus 1 over 2x plus 1, okay? So now, after we simplify that, we can then use, okay, approaches to negative 1, since the negative 1 won't change the whole thing, so you can just directly substitute it to it, okay? So we have to write exactly what the question wants. So the limit of x approaches to negative 1 of the f of x, which is equals to 3 times negative 1 minus 1 over 3, this is a 2. 2 times negative 1 plus 1. So this is negative 4 over negative 2 plus negative 2 plus 1, which is negative 1. And that's equals to a 4. Okay? Now, part 2. Now, part 2, since the f of x, we can then already simplify as 3x minus 1 over 2x plus 1, right? So it approaches to the infinity. When it approaches to the infinity, it means we have to find the approaches to infinity means to find the end behavior. Okay? So how to find the end behavior? It's we study if it has any asymptotes, right? And the asymptote is we compare the leading power. So compare the leading power. Okay? If the leading power of the top and the bottom, they are the same, then the end behavior or the horizontal asymptote will be their coefficient, okay? So the coefficient, the A over B, will be the horizontal asymptote, aka the value that is going to approach to infinity. Okay, and these ones are the coefficients. Okay, so in this case, now let's compare first. Okay, so leading power, it is actually 1, right? Okay, so since because the denominator and the numerator leading power are the same. Therefore, the limit of x approaches to infinity of f of x will be equals to their coefficient divided by each other. So which is equals to 3/2. That's it. Okay. So that marks down the end of question 11. Okay. So moving on to question 12. Now, question 12 is one of the, I would say, kind of like the hardest one a little bit. Okay. So for 12AI, the real part and the imaginary part, we just expand it a little bit. Okay. So if you forget how to do the cube identity, you just do it as the square version and then times another time. That's also work. Okay. So I do it in a slow method so that you guys can at least follow. If you remember how to do it, which is totally fine as well. So you're gonna have a squared plus 2abi plus the b squared times -1, basically, you know that. Okay, and then times a plus bi again. So you distribute it, then you're gonna have a cube plus 2a squared bi minus a square, not a square, a b square, okay? And then plus the a square bi, then plus the 2a b squared times -1 because I times I. Now the last one, that's actually positive times negative, which is negative b cubed and then with a little I, okay? So if you combine the like terms a little bit, okay, a squared bi, a squared bi, these two can be combined, okay? The next like terms are a squared minus ab squared, ab squared, okay? So we can then write it out as what? As a cube and then minus, basically minus 3ab squared, okay? And that's the yellow part. That's the yellow part combined. Then we're gonna plus 3a squared b minus b, but then close bracket y because we want to group and factorize the I out of them. So this is b cubed, okay? So therefore, the real part of this is a cubed minus 3ab squared. That's the for I. For a2, imaginary part of theta is 3a squared b minus b cubed. Okay. So far, so good. Okay, so then now move on to b. Now, Hansel otherwise showed that 1 plus root 3I got cubed equals to -8. So that means actually we can compare the like terms. So a is a 1, b is a root 3. So that means a is a 1, b is a root 3. Then we can just use the real part, right? Therefore, it's gonna be equals to what? It's gonna be equals to the 1 cube minus the 3 times the 1 times the b square, which is root 3 square, right? Okay. And then plus bracket 3 times 1 square times the root 3 minus the root 3 cube times the I. So you're gonna have 1 minus 3 times the 3 plus that's this what? This is basically 3 root 3 minus now root 3 times root 3 times root 3, root 3 times root 3 times root 3. This combined as a 3, right? So it's 3 root 3 minus 3 root 3. So these two cancel out equals to 0, right? Then you're gonna have 1 minus 9, which is equal to -8. You successfully proved it. So Moving on to part C. Now, part C, Z3 equals to -8. They are the solutions. They are the roots. Okay. Now, pay attention here. V is belongs to the real numbers. So for sure, this one, it will have an opposite root because if it is a plus, then for sure the other root, now we have what? We have u, we have v, we have w, right? U is given 1 plus 3 root 3i, okay? That means for sure, another one, the other root has to be, it must be 1 minus root 3i. But you have to assign it to which one. And it tells you that this one, the v has to be a real number. This one has to be in real number, right? So this contains the imaginary root. It has to be belongs to the w, okay? Like this. Okay, so how do we find a v? It's like this. So v times your 1 plus root 3i times 1 minus root 3i, that equals to -8. So combine these two, a squared plus b squared. So 1 squared plus the root 3i squared. Oh, sorry, it's not plus, it's a minus. And then times the v equals to -8. So which is v times 1 minus 3 times -1 equals to -8. So which is 1 plus 3, that's a 4. So v times 4 equals to -8. V equals to -2. Okay, so that's how you find the 3 solutions. Okay, so now, and then write down these ones in the Cartesian form. Okay, so how can we write down our answer in that particular format? It's pretty. Did we find it? Oh yeah, we already found it. So just pretty good. So for part D, find the area of a triangle. Now, if we want to plot it out, the area, right? We first of all need to draw the grid. This is the real part. This is the imaginary part, right? So for the V is pretty simple because the V is actually at -2, right? That's gonna be the V, okay? Then the the U is 1 plus 3 root 3i. So that means it's gonna be go to the right by 1 and then goes up by root 3. So if I labeled it correctly, then I'm gonna have this is a 1. That's gonna be root 3. So this one is the U. Correspondingly, 1 minus at this one is negative root 3. So this point will be the W. If we sketch it out, then the triangle shall look like this, right? So for this triangle, you can see that's the base, right? That's the base. And then this one should be the height, right? So base times height over 2. So for part D, the area, it's base times height. The height, it's 1 minus -2. Okay, times the base. The base is now you see that actually across root 3 to negative root 3. That means this is root 3 and another root 3, which is 2 root 3s, and then divide by 2. Okay, so which is 3 times 2 root 3 over 2. So divided to 2, cancel out, that will be 3 root 3. Okay, so that's it. Okay, now it's gonna be rotated. It's gonna be slightly rotated, right? So now this is a little bit tricky because let's copy down the grid first of all. All right, this is -2. That's 1. That's root 3. That's negative root 3. Okay, here and here. So if I have to do it, that means we have to find the angle first, right? Then move to it's going to be what? Rotate it anti-clockwise about 45 degrees. Then we have to basically add power of 4 to it. This one also shifts here by power of 4 to it, okay? So let's find the easiest one, which is this is the V, what is the W? W at the bottom, U here, okay? So the the V prime should be at here, right? Should be here with the length of still a 2. So if you remember how to write the format, you should be writing it as V should be still a 2. So that means the V prime, that's equals to 2 times what? Times e to the power of, because that's originally, that's going to be 180 that means a pi, right? Which is pi plus another pi over 4. Okay. Okay, makes sense. So that means this is gonna be 2, and then of course with you we have to write down the I on the top as well. So 2e, and then this is 5 pi over 4. Okay, okay, makes sense. Okay, so if now you can also write in this way. So if you go this way, by 5 pi over 4. In another sense, that means you go backward by how much? By -3 over 4. Okay, so you can write that as equals to 2e and then -3 pi over 4 as well. This is also okay. Okay, so that's the first point. Now the second point, it's the u. If we take a look at the u is from here, right? But then now the length, we have the height, we have the width. The base is actually a 1. The height is a √3. So you remember from the famous triangle, that's 1 √3, the remaining has to be a 2. So that's a 2. And then this one has to be a 30 degree. So which means the base angle, this one is a 60 degree or pi over 3, right? So that means the u prime, the new u prime, it will be what? Still the 2, the length is a 2, right? Because we take the radius a little bit. So 2e to the power of originally pi over 3, and then anti-clockwise means plus the pi over 4. So if we add it up together, then of course with the I, so which is 2e cross multiply, the base is a 12, and then 7 pi over 12 I. Okay. Yep. The new point will be like there. Okay. This is the u prime. Okay. Now the last one. It's the w prime, right? So w prime. Now w prime is a little bit special because you see this is the w. This is actually going down by -√3, right? That's the 1. The hypotenuse is always the 2. It's the same reflection, but this is -√3. So the -√3, you clockwise, anti-clockwise by power of 4, that should across the 0 line and approaches to here, somewhere around that. Okay, so that means the w prime, it will be what? It will be still the 2, the radius, and then e, and then to the power of -pi over 3 plus how much? Plus the pi over 4. So that will give us the, and then to the I. Is it still to the top a little bit? No, that's going to be if we use negative 4 pi over 12 plus 3 pi over 12. Oh, so it's only -1. So not even on the to the top. So not even to the top yet. So if we cancel this one out, then the point maybe should be just slightly like there only. Okay. So that means the answer, W prime, is 2e to the power of negative pi over 12. Okay. So we successfully found the 3 points. Okay, so that's the part E. Now part F. Part F, what is that? Okay, find the value of D if the solution. Oh, so again, part F pretty straightforward. Just basically multiply everything together. Okay, so that means the U prime times V prime times W prime. Okay, so what does it give us? That will give us 2 times -3 pi over 4 2 times e negative 3 pi over 4 I times 2e to the power of 7 pi over 12, 7 pi over 12 I times 2e to the power of, just now it's the last one, which is the w, which is negative pi over 12. Negative pi over 12. Okay. Number times number, 8. These ones with the exponential rules, you just add these three things up. So if you simplify a little bit, this one is actually negative 9 pi over 12, right? Plus 7 pi over 12, right? And then plus the basically minus pi over 12, okay? This one to the power of I. So that equals to e to the power of, now negative 7 plus, negative 9 plus 7 is negative 2. Negative 2 plus minus 1 is negative 3, which is negative 3 pi over 12, and then I outside. So that's equals to, that's equals to 8 e to the power of negative pi over 4I. Okay, makes sense. Makes sense. So that means in this case, we have the we have basically the same thing, and then we rewrite it as 8 times what? The 8 times the e, right? The e, how can we do it? It's the cosine of negative pi over 4, and then plus what? Plus I times the sine of negative pi over 4, right? So we're gonna have now pi over 4 cosine negative pi over 4, which is 45 degrees, right? And that's gonna be 1 over root 2 positive. So which is 8 times 1 over root 2, okay? And then plus sine of that, which is negative, then which is plus the negative 1 over root 2 times, so like that, okay? So if you simplify, you're going to have 8 times root 2 over 2 minus root 2 over 2i, which is 4 root 2 minus 4 root 2i. So c is 4 root 2, and d is negative 4 root 2. Okay. So now moving on to the last one. It's given that it's what? These six points are all the solution of z to the power of n equals to a for some a belongs to that, where n is belongs to the numbers, okay? And then what is the smallest value of n? Smallest possible value. So if we list them out, there's already 6 points, right? So, and each of the 6 points for part G. Now, each of the 6 points, if we sketch out a little bit now, the original points are here, here, and here, right? After a shift, that's going to be here, here, and more 45. That's going to be here, right? Okay. So these points are actually not on the same spot, no overlapping, right? That means the number of roots should be what? Should have at least 6 solutions already, right? Or n should be at least 6 because you already have 6 different points up there. Okay. So if we list them out all the points with the angles, first of all, we have what? We have the we have the original for the v. For the v, that's gonna be pi, right? For the u, that's the positive one, which is positive 60 degrees. That means pi over 3. And then the w, original w, that's gonna be negative pi over 3, right? Okay. Then the v prime, that's gonna give us negative 3 pi over 4. The u prime, that's gonna give us what? That's give us the 7 pi over 12. The w prime give us negative pi over 12. Okay. So now these six numbers, if we want to see it happen, or they have to be the solution for that, at least what? We want them to be exactly one period or exactly a multiple of 360 degrees or multiples of 2 pi's, right? So that it's actually reverted and then back to the same position, okay? Or at least have the same result, okay? So that after it got multiplied, they will end up on one particular point for all of these 6 points. For all of these 6 points. Maybe here, maybe somewhere else, but at least they have to multiply a certain number, repeat it for so many times, so that this one they have to be right on the same point. And because that this one has to be, they have to be the multiples of 2 pi. Okay. So how many times do I have to multiply this one to be the multiple of 2 pi? This one, the first one, I have to multiply by 2 only, right? So this one, how to be the multiple of 2 pi? I have to times 6. This one also times 6, okay? Because negative is just, it's the same, okay? This one, multiply by how many to become a multiple of 2 pi? So we have to multiply. Again, it has to be a whole number. So it has to times 4 first, right? Times 4 to get rid of the denominator. And then so after get rid of the denominator, it becomes 3 pi, right? And we want them to be a multiple of 2 pi. So I have to times another 2 again, okay? So that means becomes 6 pi. So that means that actually becomes multiplied by 8, okay? This one multiply by how many to be a multiple of 2 pi? I have to times 2 first to get rid of the bottom 12. Then 7 pi times how many to becomes a multiple of 2 pi? I have to multiply 7 again. No, 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 7. So multiply by 12 first. They have to multiply by 2 to become 14 pi, right? So it's multiplied by 24 times, okay? So this one, again, how to make it the multiple of 12 is multiplied by 12, becomes a pi and multiplied by 2. So it becomes multiplied by 24 times, okay? So after that, it will be what? It will be all of them, all these points will be the multiple of 2 pi. And hence they can actually turn and overlap on the same point, okay? So what is the minimum point that we can actually achieve it? We pick the biggest one here. In this case, it's 24. Therefore, n is equals to 24, okay? If there's 20 likes for this video, then I will make the paper 2 explanation for you guys. And also please comment down below if you have any questions or any comment on my videos or in this paper. Thank you guys.